And our first of the final three headline sessions comes to World Summit AI, somebody who has published over 100 papers and is the inventor of some 45 patents. How about that for a record? He pioneered some of the early technologies for the effective analysis of big data, internet privacy, and contextual search. It's no wonder that he's Vice President of Engineering at Google. Please welcome on stage Professor Yossi Matias.
Hi, everybody. It's great to be here. Thanks for inviting me. And AI is obviously a fascinating topic, so it's great to see so many people here. So I thought I'll give some reflections and talk about some opportunities about AI. And obviously, AI is a big topic, and I know you're after 2 days of hearing many, many talks about it. But let's go perhaps to some of the genesis of AI with Alan Turing already asking questions about, are computers going to be able to interact with people in a way that is going to be indistinguishable from other people, also known as the Turing test in some framework. And obviously, many of us grew up on the notion of a Star Trek-like experience where we can actually talk to a computer, getting the AI system do stuff for us. And this has been kind of an aspiration. But if you look a little bit into some of the developments, in fact, it wasn't really a linear development. There was a pretty impressive piece of work by Samuel in the late 50s, writing a machine learning program that was playing checker and was actually pretty good. It took first place in the United States in one of the tournaments, and it used some pretty interesting techniques. Not a lot was developed over a course of the next couple decades. In fact, when I was an undergrad student and I was fascinated by the premise of machine learning, I was actually quite surprised to discover this was still the state of the art. My project, by the way, was using some of these techniques with a few hacks to play reversey. And I was quite surprised that after a few days and nights, this program could actually beat me and everybody else who tried it. But also it crushed the computer system. So I learned even firsthand that computing resources are crucial to have some good machine learning. A big breakthrough was in 20 years ago when Kasparov, the unbeaten world champion, was actually beaten by a computer program where everybody was kind of starting to ask questions about what does it actually mean to have AI that beats the world champion in such a pretty so convincingly. And in a way, others could think, well, at that time, we already had pretty good computer chess programs that could beat most people that were not world champion. But actually, I think that the real revolutionary step was just a couple of years ago when we had AlphaGo, which was developed by our colleagues from DeepMind, surprising, in fact, shocking much of the world by beating the number one ranked champion, Lisa Dahl, in a play of Go, and in the process also, in a way, coming up with some innovative steps, which was quite surprising. People did not expect a computer program to actually do this kind of milestone anytime soon, and this was already leveraging some of the more newest technologies. But this was actually not the last chapter on that game, because a year later, there was AlphaGo Zero that was very convincingly beating up many Go players. And the interesting part about AlphaGo Zero, and this was a paper published in Nature about it, was that unlike AlphaGo, which learned from actual games of players, AlphaGo Zero actually trained itself by playing against itself, using all sorts of new techniques of deep neural networks. Now, these were all kind of games, and it's a game is a good benchmark to see some progress, but obviously quite often what we really care about is what happens in real life. And when we think about this progress, which is accelerating recently, if we look at it from a scientific point of view, we can see here the chart of the number of papers on machine learning published every year. And this actually goes faster than Moore's law. And we see plethora, so many of you may know that the NIPS conference, which is one of the primary machine learning conferences, opens its registration, actually was sold out 10, 11 minutes after starting the registration, with thousands of people registered. So obviously machine learning and AI is a hot topic, many people making a lot of progress. Now, if we step back for a moment and ask ourselves what really happened, how did it reach into this kind of obviously, the big step that we had in the last few years is around deep learning, neural networks, which benefits from a combination of using based on some techniques that were already known quite some time ago, but now leveraging on new models, new architectures, more computing power, more data to work on, and essentially making breakthrough in how we apply machine learning on identifying patterns in data. And of course, this can be applied in many domains. It can be applied on images, where we take pixels and we actually understand that this is a monkey. It can be applied for audio, where we take audio signal and we can actually learn what are the words that are being spoken. It can be applied on taking sentences and being able to then learn how to translate it into another language, all based on models, based on training of many, many languages. And again, it can be applied on taking pixels and identifying pieces within an image, among many other things. So if we just illustrate the progress that we've done on images and just translate the mathematical errors into the actual application, then one illustration is this image, which back in 2011 was pretty blurry with about 26% error. And then where humans are estimated about 5% error. And here we're actually, even a few years ago, got into a stage that we can have machine learning programs that can do a better job than humans, which is a twist in what we can do with technology and how we can apply it. So I'd like to touch on 3 areas that this has ramifications looking forward. And obviously AI is going to change things in many aspects of life. It's going to impact businesses, it's going to impact infrastructure, it's going to impact transportation, and many other fields. And I would say that we have a great opportunity to actually make a very positive impact in all of these areas. So let me briefly touch on 3 of them. So the first one is about health. And health obviously is one area that it's quite clear that if you can use technology to solve problems, then this can actually help people in a profound way. It can save lives in a pretty significant way. And a good illustration for that is now pretty well known, diabetic retinopathy, which is a condition which puts at risk essentially every person with diabetic. People with diabetics need to have screening typically once a year in order to, and this is treatable condition. Now, if you don't get the right screening, people can go blind. And there are quite a few people who could actually go blind if not getting the right screening and the right treatment. And the way the screening is being done is by taking a picture of the eye and then looking at the image and identifying by experts the spots that would identify the condition. Now, as it turns out, there's a lack of experts who could do that kind of screening. And the estimation is that just in India, there's a shortage of over 100,000 eye doctors that could do that. And the implications are pretty bad, of course. So it turns out that because this is really an image understanding kind of problem, and as we know, one of the advances in AI was about understanding images pretty well, there was a lot of work done on this particular problem and showing that we can get into identification which is in par with what we can expect from experts. And therefore, we can actually utilize this kind of AI and machine learning in order to really help out those who otherwise would not get a screening, which is hugely impactful and encouraging, and there's already a pilot going on to try and integrate that and incorporate that. And to me, this is kind of a very powerful illustration about how using technology we could actually impact people's life in a pretty profound way. And I'm pretty sure that we can do that in many fields, and it's of course, we see a lot of emerging industries, emerging startups, and obviously we're doing a lot of that at Google as well. Just to touch on another area which again impacts people's life quite profoundly is the notion of crisis. And crises are pretty diverse. We have earthquakes, we have floods, we have a crisis of which are man-made, unfortunately, terror attacks. And one thing that we learn is that during crisis, one of the most important things for people is to get the right information, the right actionable information. And this is reflected, you can see in the charts, the peak in the number of searches during a crisis, the number of searches during floods in Chennai, where people are looking for information about floods. And I personally remember an experience of having a wildfire not far from our office in Israel, where the first thing I was doing is actually looking for information. And if the information was not there, then this was actually this was more than frustrating. This was actually dangerous. So information is critical in times of crisis, and we set up to address it by launching about a year ago a product, a feature called SOS Alerts, which essentially tries to bring very quickly during crisis information about what's going on, where is it happening, and what people can do about it. And since then, we had over 200 activations. We had over 1.5 billion views of information coming up from these SOS alerts and also public alerts that we had before. And these are all helping people in a pretty profound way. Now, as it turns out, the most deadly crisis is the floods, where there are some estimated 250 million people impacted by floods every year, and thousands of casualties. And the problem with floods is that if you know that they are going to come, you can actually take some action, as reflected in information that we had around floods around the Hurricane Irma in Florida, where we got this kind of feedback, which is reflecting. If you know that you need to take action, you can actually save your life or somebody else's life. The problem is that in most of the world, we don't have this information. And that's actually where we identified an opportunity to apply machine learning in order to get better information. So we, in partnership with the government of India, getting gauge water level focusing on a Patna area in India, which has some of the worst floods out there, we applied machine learning technology in order to get better elevation data of the geosurface in that area, and then use hydraulic models and simulations and a lot of computational power in order to try and predict more accurately where floods are going to occur in situations of riverine. And indeed already launched the first activation in that area, so that a few hours before the flood is actually going to occur, people got information about here's where we expect, in a pretty high confidence and high accuracy, the exact location of flood, so that they can take action or that the responders can take action. So this is the kind of indication for the opportunities that we have. And this is really scratching the surface on opportunities, because if you think about many other crises, the opportunity to apply machine learning and AI to take some action, to learn better information, or to do a better prediction about what's going on, and therefore save lives, is pretty profound. So really exciting to see some of progress along these lines. Now let me switch to a third area, which I'm particularly passionate about, which is conversational AI. And again, if we go back to the Alan Turing challenge, it was about conversation. If you think about the Star Trek experience, it's about conversation. And it's no coincidence, because conversation is really the natural way in which people are communicating, in which we express ourselves quite often, in which we learn information. And progress in conversational AI could be quite significant on many levels. So let me touch on that a little bit. And what do I mean here by ambient intelligence? So taking a step back and thinking about technology, one ramification of technology development, which we experience quite significantly, is that it has impact on how we interact and how we do our business or private matters on a daily basis. And sometimes it's positive, sometimes it's less positive. I remember 20 years ago when speech recognition technology started to be good enough for people to use for their phone systems, that we started having this frustrating experience, and I'm sure many of you can remember that or perhaps still experience it, where instead of calling somewhere and asking a question, you're calling and you're getting this automated menu, which is unpleasant and starts navigating you through a system which wastes your time. So that's a situation that is undesirable, of course. And at the time, I used to think about it as, in fact, borrowing from a research that was published around that time in Princeton as the revenge of technology. And the point was that technology actually did not make life better. In a way, it added a hurdle. And if you think about how we're using technology in many cases, it's not always as accessible to everybody as we'd like it to be. And the most natural interface that people have for technology or for surrounding is really conversation. Now, what do I mean by ambient intelligence? The best way in which technology can be utilized in our daily work is to be embedded, to be ambient in what we're doing, to be seamless, to just work. Just imagine that you could take any problem that you'd like to do, and you could just address it like clicking on a button in an elevator to get somewhere. And elevators, by the way, there was some technology out there at some point that you needed more than clicking on a button. Or think about cars. A few decades ago, you needed to do more than just get into a car and start driving. Right? And today you don't need, people don't need necessarily even to know how to shift gears. And probably in a few years, driving itself is going to be optional because it's just going to do the work for you. And if you think about it, many technologies around us are actually becoming successful where ambient, where they just work. So the question is, can we actually get our interaction with technology to be just like that? Now, some of the most exciting advances that we have in technology, which is also powered by machine learning techniques, is that of speech recognition and speech understanding. Speech recognition and also speech generation. So what you see here is the chart of speech recognition, and we've seen this amazing progress in the last few years, and now in some situations the recognition is better than you'd expect from a human. Whereas on speech generation, we're actually getting there, and in some cases, we are in par. So these two technologies obviously are important for any conversational experience. They are not the only one. In order to really have a conversation, you need to understand the conversation. And you need to want to make it natural. So obviously, one advances that we have based on these technologies is the Google Assistant and related technologies, where you can just ask a question. And the difference between that and setting up, and this is a great example for ambient technology in the sense that here you can see a few ways in which people are asking questions, or asking to take an action. In this case, is to set an alarm clock. There are multiple ways, and as long as the technology is good enough to just understand it and just do the work, that's just like clicking on a button. And of course, what we see today is that because of the voice interaction so natural, then a good fraction of searches at Google on mobile are actually by voice. And a good fraction of those are questions which people are just asking the question as they would ask another person. So there are many more advances that can be done here, of course, once you start getting this interaction. So let me highlight three that I was particularly busy with my teams working on, and are all about how to interact with the world. So first is the following question. Suppose, given that we can actually now have this speech generation, which is so good, could I actually just listen to any page on the web instead of reading it? Because quite often some people perhaps may have difficulty reading it, either because they don't know the language good enough or because they are driving or busy doing other stuff. So we actually launched recently in India in an app called Google Go, the option whenever you see a page, you can actually just click on a button and just listen to the page instead of reading it. Or actually listen to the page while reading it, because it's going to have a karaoke style kind of listening. So that's an example for technology that was not possible in the past. And now, just imagine, instead of having people walking in the street watching the stream, if you could actually have them just listen to whatever content they'd like to consume and have their eyes out there. So that's kind of a hint into what the future actually may enable us to do with this technology. A different one is, when you think back about the assistant, I gave the example of setting an alarm clock, but obviously there are many, many actions you'd like to take on them. And people are, for example, people asking for restaurant reservations are now, if they, quite often they could use the assistant to just make reservation. And if the restaurant has an online booking, then they're just going to have it reserved for them. The question is, what do you do if you don't have online booking system for that restaurant? And it turns out that, for example, in the US alone, 60% of businesses, small businesses, do not have booking system. So can we use technology to reduce that friction? So we actually developed technology called Duplex, where the aim of that is actually help you get this task done on your behalf. So the idea here is for the user to still make a reservation on their assistant, just asking, make me a reservation tomorrow, 7 o'clock, or between 7 and 8 in a particular restaurant, and to just work. Just get to the restaurant, have a, and be seated. We don't want people to actually do calls that they don't need to, right? And this is enabled by technology that then the assistant can make a phone call to the restaurant and have the conversation in a way which is natural. And the reason why this is possible is a technology which is based on a combination of various technologies where we take the audio signal through automatic speech recognition, through a deep network, and additional technologies to actually generate the conversation. And of course, we need more technologies to understand the interaction and to make it sound natural so that we don't introduce friction into the side of the restaurant. We actually want the conversation to be natural. So Duplex technology enables this kind of interaction in a very natural way. And finally, let me give another example for how we could take technology and reduce friction. And this goes back to actually an older technology, which we all are familiar with always, which is the phone. So we're all familiar with the problem of having calls in undesirable hours. We're in a meeting, we're giving a talk, etc. And a growing problem in the world, of course, is the problem that many of these phone calls are actually telemarketing, are spam calls. So we actually just a couple of days ago announced a feature in the Pixel phone, which is called Call Screen, where if you have a call from an unknown number, you can click on a call screen option, and the caller is going to hear a message about asking them for the purpose of the call, and then whatever they're going to respond is going to be transcribed in real time so that the owner can make a decision or ask a follow-up question and have kind of a small interaction without actually picking the phone, and then decide whether they'd like to pick up the phone or just end the conversation, perhaps even report spam. So in a way, this is technology which is based on voice recognition, which is good enough to actually run on the device itself, on the speech generation that can actually talk back to the caller in a good way, enables us, frees us from the need to answer any phone or have the dilemma of, is this an important call that I'm going to miss, or is this a call I'm going to answer, which is likely going to be a spam call. In a way, it's a technology that can enable us to never need to talk to a telemarketing again over the phone, which I think many people are pretty excited about. And this is enabled by these advances. Now, to me, this is an example of how we use technology to give us back our time, to give us back our control. And I think there are many more opportunities that we can actually do that. So I'm just going to finish in 1 minute of just touching on one topic, which is not about the exciting aspects of AI, but on the responsible aspects of AI. Obviously, like every new technology, AI is a very powerful technology, and we need to use it with responsibility. So I do want to highlight that We just recently published principles, AI principles, which are principles about be socially beneficial, avoid creating and reinforce unfair bias. And bias is a big topic in AI because, as we know, if we just train models based on available data, we could take bias which already exists and actually amplify it. And in a way, we do have the opportunity to use AI and tackle those biases and make better selection processes out there in many systems, I believe. We want to build for safety. We want to be accountable. We want to incorporate privacy design principles in everything that we do on AI and uphold higher standards of scientific excellence. And again, with AI, you can very quickly hack a lot of stuff. So I think that developing it with scientific rigor is hugely important. And finally, to be made available to users according to these principles. So I think that these principles, and there's a lot of effort going on many teams at Google and other companies as well, and a lot of research in academia, and I think these are hugely important topics that we all need to pay attention to. And I should just note that at Google, I'm not going to stop on that, but at Google, we're doing it in many offices around the world, and thank you for your time.
It all makes sense. Yossi, thank you very much for that. Really appreciate that conversation. Yeah. Can I open some questions to the floor? Is that okay with you? Wonderful. Quick questions to Yossi in the last few minutes that we have. Please raise your hands. For Google here, gentleman at the back over there, just making our way. If you could stand up for me when the microphone comes to you. Thank you. If we've got time, we'll come to you next as well. Thanks.
Yes. Hello. This is Tom Nijbroek. The phone call technology that you displayed, is it also explicitly made available for deaf persons, or is it just a happy coincidence?
What was the question? I'm sorry.
A happy coincidence, or is there a desktop version? Is that correct?
No, for deaf persons. So the voice-to-text feature on what you displayed was spam calling.
Yeah. So for how that software is available?
Yeah, so this is obviously a first step. I think the opportunities here are immense. Once you open up, once you incorporate these various technologies for text-to-speech and voice recognition, and this is an example for actually taking that, incorporating it in a way that, in a way, is a cross-modality interaction. One side is using a screen, and the other side is actually having a conversation, and they are on the same conversation. Of course, you can apply your own imagination of where we can take it, which I think is pretty fascinating.
Thank you. And just gentleman over here at the front. Hi.
Hi. Johannes from Estonia, CEO of Psychic. Thank you for the great presentation. My question is about, if you look at the advancements, exponential advancements of conversational interface, so the question is, how many years do you think until we crack the Turing test?
How many years did it
so,
take? Okay.
So that's an interesting question. Many people would argue that the test as was defined many years ago is not that relevant. In many domains, computers are actually doing a much better job than people, including, by the way, driving in many circumstances, much to our dismay perhaps, or not. So for general conversation, I think we're pretty far. What we see advances are, for example, duplex technology, which is very powerful because it actually manages to complete tasks in the majority of conversations, is narrow domain kind of tasks. So it's about reservation for restaurants, hairdresser, and the like. To have a conversation which is totally open and where you can expect a computer to have an intelligent conversation which is totally vast, I think we're very far from that. But if you take specific tasks, then we see that on many specific tasks, then AI is doing actually a much better job than people, which again is a great opportunity for us because then we can focus on other matters that actually require our attention.
Thank you. Yossi, it's great to have you here representing Google today. Thank you so much for your time. Yossi, Matias there, thank you.